In this video, we want to start the modeling of a generator that is connected by three-phase line to a load. So this is a three-phase system, and we want to start the modeling of this system. Okay, so here, if we go to the uh, library of the Simulink, here in Simscap, electrical, specialized power system, we have the three-phase items here. So the first step is putting a power GUI here and changing the simulation type to discrete with the default sampling time, and okay. So here, first we need synchronous machine. So if you click on electrical machines, here we have this synchronous machine controls. You have DC machines, you have different generators and motors. So when it's machine, it can be operated at both generator and motor. So here we have simplified synchronous machine in per unit. You can put it here, and it's working with per unit. So here we have some input, PM, and E is mechanical power input and voltage here, and we have the three-phase output here. So for connecting a transmission line, if you go to a specialized power system, here we have the power grid elements. If we go down, here you have three-phase line. And we need a load. If we go into passives, here we have different RL and RLC loads. Here, there's a load that we could have is grounded. And we can connect all together, but we also need some measurements here, the three-phase measurements. For single phase, we could use these current measurements, but for three-phase, we also have some three-phase VR measurements like this. So if you connect together, so is a measurement, we have voltage and current in output, and here we have the load, so it's connected. But we need some inputs for our generator. If you just search constant, here we have a constant value because it's on PRM. It should be on it's on per unit. It should be something on per unit. If you double click here in the generator in parameters, here we can change the nominal power, line to line voltage, and frequencies here. Other parameters for machine is also here. So let's change this nominal power from 187 mega to 187 kilo, and okay. And here we have a load. Load is 100 kilowatt, and the line is 100 kilometer. And we need some scopes here to see the output of voltage and current. We can also reduce it to 0.2 second, and when you click run, here you can see this is the voltage and this is the current. So you can see both together. And from the voltage side, we have some voltage drop. If we want to see how much power is delivered, here also we have this power positive sequence. This is on the measurement tab, sensor measurement tab. Here we have this one. So it should be connected to output of the three-phase measurement, V and I. And you can copy and paste two sensors here, and easily you can see the delivered active power and also reactive power, because the measurements it's on this side before the line, and the line is 100 kilometer. You can see here the power is much more than 10 kilowatt, because the load was 10 kilowatt. Here we have it was 100 kilowatt, and now we have delivering of 150 kilowatt.